Hi, I'm Tom, and in this tutorial for FreeCAD BIM I will show you how to model this simple table which you can use in your BIM projects. The table model is parametric, so here I've got width, depth and height parameters and I can change them, and if I change the parameter the table changes its width or the depth or the height. Even though this tutorial is meant for BIM workbench users, we will model this table in the part design workbench because this workbench is meant to model objects like this one. You could also watch my previous tutorial where I created a chair using the part workbench, so you can see the differences between part and part design workbenches, where part design workbench creates one object, a body, which contains all of the table geometry. You can download the finished model from FCB Launch Shop for free, and the model is created in FreeCAD 1.0. Okay, so let's get to it. In FreeCAD, I will start with an empty file. So I have a new empty file, and here I will make sure that I have got the part design workbench activated because we will model the table in this workbench. So first off, in part design, you have to have a body. This is the basics of part design, so I will create a body, and if I look at my model tree, I can see that I have got the body and an origin. And I will be creating the geometry of the table inside of this body. If I click away, you can see that the body is highlighted in green color. That means that the body is active, and if I'm creating new geometry, it will be created inside of the body. If I right click the body, you can see that it's activated, and I can deactivate it by unchecking this active body. So now if I click away, the body is not active. So this is important concept of working in the part design workbench. So I will now activate this body again, so I'm working inside of this body. So first I want to create a table desk, and I will create a footprint of a table desk and then extrude it. So to create a footprint, I will click this, create a sketch, and it asks me on which plane I want to create the sketch. And if I want to create the sketch looking at the top of the table, I will select the XY plane, and if I click it, it opens up the sketch workbench, and now I'm working and creating the sketch objects. So now I will select the create rectangle tool, and I will click here and create a random rectangle. Now I will hit escape to escape the rectangle tool, and you can see that the geometry is not constrained, so I can click and drag it like so, and it's not constrained, so we have to constrain the geometry. The first constraint we will do is we will constrain around this center point, and we do that by using this constraint symmetric. So I will fire up this tool, and now I will click this point, and then the last constraint point, and make sure that you are not clicking the line but the point. So I will click on the point, and now it constrained these 2 points at the center here. I will hit escape, and now it's constrained symmetrically around that point. So if I drag the lines, you can see that it's always symmetric around the center point, which is very helpful. Now first off, we will model the table as not being parametric, but I want to constrain this length. So I will select the line and use the dimension tool and click the dimension here, and the length I will set to be 1400 millimeters, hit OK. I will zoom out, and then I will click on this line, click here, and I want this to be 800 millimeters as a basis of the size of the tabletop. And you can see that the sketch is fully constrained, which is what I wanted. So now my sketch is created, so I can close the sketcher by clicking close. And you can see that I created a sketch inside of the body. If I now want to see it here, I will use the zoom tool to fit all, so I can see the sketch here. And if I did a mistake and wanted to change the sketch, I can just double click it in the project tree, and I'm back in the sketcher, and I could change the dimensions or constraints, but I will not do that now. What I want to do is create 3D solid from this sketch, so I will select it and use the pad tool, which creates an extrusion from this solid. So I fire up the pad tool, and here I have the settings of the pad. And you can see if I change the length to, let's say, 50 millimeters and click here, it's extruding upwards. I want the sketch to be the top of the table, so I will set the length to be 50, and I will click reversed, so it will be extruded downward. So I will click reversed, and this is how I want my tabletop to be, so I will click OK. So we have got the table desk correctly created inside of the body. Now the top of the table desk is placed in the point 0, 0, 0, so it's at the Z elevation of 0, and I want to place it 750 millimeters above what will be the floor for me. I will do that by going to the pad and clicking this rectangle so I can see the sketch, because I want to move the sketch. So I will select the sketch, and in the properties I will go to the data properties, and here in the attachment I have the attachment offset, so I will click down here and click down position, and in the Z axis I will change this to 750 millimeters, hit enter, and you can see that when I move the sketch, the pad is moved too. So this is nice. The top of the table is placed 750 millimeters above what is floor for me. So the tabletop is created, and now I will create legs. So I will fire up the create sketch again, because I will create a new sketch as a basis for the leg, and I will use the XY plane again because I want to create the footprint of the leg from the top view. Now I will draw a rectangle again, so I will click here, and here I will draw it by hand, and you can see now if I hit escape that I cannot see the sketch. We have this switching option, the view section. If I click it, I will not see the geometry, and if I click this view section, I will see the geometry of the table. And actually I will first hide it, and I want to constrain this length, so I will click like so, and it will be 50 millimeters, and I want to constrain this length, and I want to have the legs 50 by 50 millimeters. If I hit escape, now I can drag the position anywhere I want, so I want to constrain this, and I want to constrain this relative to the tabletop size. So what I have to do is show the tabletop, and I cannot use the dimensions from the geometry that is not inside of the sketch. So what I have to do is I have to bring in an external geometry into the sketch that I'm working in. And I do that by using this tool, create external geometry. So I will click it, and I want to bring in just this point, not the line, but just this point. So I will make sure that I click the point, and you can see that the point is brought inside of this sketch. And now I can switch again it's enough for me to just see the point. And now I can use the dimensions relative to this point. So I will use the dimension tool, click this point and this point, so the corner of the leg, and let's say I will make it 60 millimeters, hit enter, and again this point and this point, and make it 60 millimeters. So the leg is always 60 millimeters from the corner. So we can see that the sketch is fully constrained, and now I can close it. So now I have the sketch and I want to pad it again, and I want to make it extrude it and reach just this face, because we will have the height of the table parametric, so it will always end up at this face. So I have the sketch selected, and I will use the pad tool again, and in the length I will not type in the length, but I will choose this type, drop down, and here instead of dimension I will use up to face. And if I rotate my view and select this face, you can see that it selected the face, and it extruded the pad up to that face. So this is what I want. I will hit OK, and I've got one of my legs ready. But of course we want to have 4 legs, but instead of creating each leg one by one like I created this one, we can mirror this leg around this axis and then the other axis. So to mirror objects, I will select the leg and I will use this MultiTransform tool. When I fire it up, it opens up here, and I have the pad 001 selected, which is the one that I had. And here now I can right click to add the transform. So I will right click and I will use add mirrored transformation. So I will click here, and you can see that by default vertical sketch axis is selected. So it's creating this this mirrored leg. Now I want to mirror it along the XZ axis, so I will add another transformation. So I will right click here and add another mirrored transformation. And in this one, I will use, instead of vertical sketch axis, I will use horizontal sketch axis. And this one nicely creates these 4 legs as I want them to be. So I will click OK and OK. And the MultiTransform tool has created these 4 legs. So now the basic table shape is ready, and you can see that it's created as one body. If I right click and deactivate the body and I switch to BIM workbench, you can see that it's just one object, and if I select it and I would use the move tool, I can easily move it like so as a one object. So this is advantage of the part design body compared to how we modeled the chair using the part workbench. But I will go back to part design workbench. And to make it parametric, we will create a spreadsheet, and for that we will use the spreadsheet workbench. So I will switch to spreadsheet workbench, and I will create a simple spreadsheet by clicking this tool, create spreadsheet, and you can see that a spreadsheet was created. And I will rename it by hitting F2, and I will name it table dimensions like so. And to open the spreadsheet, I will double click the spreadsheet, and you can see that it's standard spreadsheet. And we want to have 3 parameters, so that I know which one is which one. I will name this one width, this one height, and this one depth. Here I will have the dimensions, but for these cells to be easily accessible so that I know which one I'm accessing, I will click this one, and important thing is how it's named, and the name of the cell is here, the alias. So instead of naming it B1, I will type in here width, and here I will type in height, and here I will type in depth. So I will know that these three columns have these three cells have these names, and in the width I will type in 1400, or let's say 1600, so it's changed. In the height I will type in 700 as in millimeters, and depth will be 1000, so that I've got at least some numbers here. So this is the spreadsheet setup, and now we want to link these numbers to the parameters inside of our body. But one more thing that is important is the name of the spreadsheet, and it's not the label, this name, the table dimensions, but here at the bottom you can see, if you hover over the spreadsheet, you can see the internal name information, and the internal name is spreadsheet. So this is important. This is how we will call the information inside of the spreadsheet. So I will switch back to my table. I will activate the body, and here I will go to the pad that was creating the table and double click the sketch. So this is the tabletop sketch, and this is the width, and this is the depth that I want to use. So here, if I click the number and double click it, it opens up the insert length information, and here I can change the length to, let's say, 1000, and it changes the length. But I want to have this length to use the number from my spreadsheet. So to use parametric number, you have to click this enter an expression symbol, and if you click that, it opens up expression editor, and here you can write expressions. And here I want to call my spreadsheet, so I will start to type in spread, and you can see that I'm offered the spreadsheet name, so I will click the spreadsheet, and then there's the dot, and you can see the cell codes like A1, B1, etc. But I know that I named the cell, the alias is width, so I will type in width, and you can see here that it offers me the width. So I will select this one. So now if I hit OK, you can see that it automatically uses the information from the table, so 1600 millimeters. I will hit OK, and I will do the same thing for the depth. So I will double click this number, click here to open the expression editor, type in spreadsheet.depth, hit OK, hit OK. And now I cannot change these numbers manually, but only through the spreadsheet. So now I will close the sketch, and I will actually tile the window. So we have got the spreadsheet next to the model, and now you can see if in my spreadsheet I change the width to 1800 millimeters, the model changes accordingly. So this works really nice. If I change the depth, it also changes according to how I change the parameters. The height is not associated. If I change the height, nothing happens. So we want to connect also the height to the table geometry, and this is how high the sketch is above the floor. So I will again select the sketch object, the one that is the base of the tabletop, and here in the attachment offset position and Z value, I will click here, and I have this expression editor option here too. So I will click here and I will start to type spreadsheet dot height and hit OK. And if I click into the space, you can see that it already changed. And if I change the height to 700 and hit enter, you can see that it changes the height according to how I changed the parameter. So this is how you create a parametric table, but to make it proper BIM object, we have to add BIM data to it. So I will deactivate the body and I will select my BIM workbench, and while having the body selected, I will create an equipment out of it. So I will click this button and it created equipment, and inside of this equipment is body, and inside of the body is the geometry. And for this equipment in the data properties, I will scroll down. IFC class is furniture, which is okay, but the predefined type is not chair, but it should be table. And the description, I can name it dining table as a description. So there's information about what this table is used for. And you can see that even though now it's a BIM object, I can still change the parameters, and it changes according to how I change the parameters. So this is still working. Now, if you wanted to use this table inside of your BIM project, you could either link it or use the simpler version just to copy and paste it. So let me now show you how to do that. And I opened up this simple project. So if I want to place table inside of this room, I would go to my table, hit Shift B as a box select, and select all of these objects, hit Ctrl C or go to Edit and Copy. And this opens up the object selection. So I want to copy all of these objects. So I will hit OK. And here in my project, I will go to Edit and use the Paste or Ctrl V shortcut. And the table is pasted inside of the project. You can see it here, and it's placed at the origin. So now I can select it, look from the top, and move it here. And I could also copy it, so I have it also in this room. So you can see that I can work with the tables here. What's a bit unfortunate is that this table dimension spreadsheet is placed outside of the equipment. So if I place these onto level 1, I have this table still here. But what's important is if I open it and I will tile the windows again, here in the project I can change the width and depth, and all of the tables change according to how I change my parametrics. So this might be useful. And now this, because I pasted it into the project, these parameters are not linked to the original table, so I can change it inside of my project independently of the original table dimensions. The last thing that I will do that I forgot previously is in the table file, I will change the name of the BIM object from equipment to table, or it should be maybe furniture 01. It depends on how you name objects, so that I know that I'm working with the table, not just some equipment. So this is the end of the tutorial. We have learned how to create a simple table which is parametric using the spreadsheet workbench, and we used the part design workbench to create the geometry. Then we also added BIM data to the table, so everyone in BIM project knows what this object is. You can download the finished table from the FCB Launch shop for free, and it's distributed under the CC0 license, so you can use it in your projects or just explore it. The link is in the description box below. If you like FCB Launch tutorials, you can support the channel by donating through the Ko-Fi page or through the Super Thanks button on the YouTube page. I hope this was helpful, and I will see you in the next one.